Okay, so this is one of the longer questions, and in every single very long question, we have parts that are basically free of charge, and it's so easy. Everyone will get all of the points. In this one, it's part C, because A and B are all proof questions. If we don't know how to use the proofs, we could just use theorems given in A and B to solve C. But A and B are also extremely easy, so no one would do that. We'd all try to solve the entire question, and let's just do it. So in part A, it is whatever this monstrosity is right here. So part A is, well, this is really straightforward. If you see two parts doing arithmetic, it is definitely doing by parts. So in is cosine nx dx. We have cosine n minus 1 x d of sine x, which means we have sine of x. Okay, let's write the other way around. Cosine n minus 1 x sine of x minus sine of x d cosine n minus 1 of x. This one's easy to differentiate, so let's quickly go through that. That's n minus 1 cosine n minus 2 of x sine squared x dx. And this one is just 1 minus cosine squared x. It's so basic, any year 7 would know this. So we have cosine n minus 1 x sine x minus n minus 1 cosine n minus 2 x dx plus, wait, the signs are wrong, so cosine differentiates, gives negative sign, so that should be pluses. Obviously this one is minus n minus 1 cosine squared x times cosine n minus 2x is cosine n of x dx. This baby is in minus 2, this baby is in, so we have nin is equal to cosine n minus 1x sine x plus n minus 1 n minus 2, which means in is equal to 1 over n cosine n minus 1x sine x plus n minus 1 over n minus 2. And that's part A. It's really straightforward. I don't see any hard parts there. Part B, we have to use mi, because there's way too many terms, and I'm not doing this term by term. So let's say pk is 0 to pi over 2 cosine 2k of x dx is equal to, well, this is for positive even integers n, so obviously n is equal to 2k, and that's n minus 1, n minus 3, so we have 2k minus 2, blah 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 to 2, 2k minus 1, 2k minus 3, blah 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 to 1. This one's to pi over 2. Let's write that more clearly. And then pi over 2 we have, so let's just do from, obviously you have to write down where n is equal to 2k, but we don't really need that. All we need is to have that at the end. So let's say when k equals 1, left hand side is 0 to pi over 2 cosine squared of x dx, and we all know we have to use this baby right here. So we have cosine squared x is 1 plus cosine of 2x over 2, which means we have we have x over 2 plus 1 over 4 sine of 2x from 0 to pi over 2. And I believe Let's erase that part because it's too easy. I believe that should be, well, that should be, let me use the calculator because I forgot how to do it. So sine pi is 0. So we have pi over 4 plus 0. So that's just pi over 4. And on the right hand side, we have 1 over 2 times pi over 2, which is just pi over 4. This means P1 holds. And then assume PA holds for some positive integer a, i.e. 0 to pi over 2 cosine of 2a of x. Dx is that monstrosity of a fraction, 2a minus 2, blah blah blah, to 2, 2a minus 1, 2a minus 3, to 1, pi over 2. And that's also quite basic, I believe, because when k equals a plus 1, LHS will be from 0 to pi over 2 cosine of 2a plus 2x dx. And the really straightforward thing we could do is to use part A, which is this baby right here. And let's just do it. This means left hand side is 1 over n. 1 over n is just 1 over 2a plus 2. So let's write that down really quickly. 1 over 2a plus 2 because of that term. And inside we'll have cosine 2a plus 1x sine x from 0 to pi over 2 plus 2a plus 1, not plus 1, but plus 2 minus 1. 2a plus 2 from 0 to pi over 2 cosine of 2a x dx. This baby is this baby right here. So we have that one's 0 because cosine pi over 2 is 0 and sine 0 is 0. Both terms will be 0. So that's 0. So we have 2a plus 1 over 2a plus 2. That monstrosity of a fraction. That monstrosity of a fraction. Blah blah blah. 2 pi over 2. Which means this is just 2a plus 1 minus 1. 2a plus 1 minus 3, blah blah blah, to 1. 2a plus 1, and that's one term. 2a plus 1 minus 2, and blah 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 to 2. So this is obviously we have the pi over 2. This is equal to right hand side. So we have PA plus 1 holds when PA holds, which implies PK holds for all positive integers k. Which is just naturals, I believe. Positive integers k, which implies 0 to pi over 2 cosine nx dx is equal to n minus 1, this monstrosity of a fraction, pi over 2 holds, oops, sorry about the handwriting, for n is positive, for all positive even integers n, n is equal to 2k. And that's for part B. And then part C is the easy part. Part C is from 0 to pi over 2. Is it from 0 to pi over 2? Yes, it is. Cosine 6x sine squared x dx, which is this baby. So we have cosine 6x dx minus cosine to the power of 8x dx. Now we could use part B safely, which is pi over 2, oops, that's not what I intended to happen. Pi over 2, 6, so 5, 3, 1, 6, 4, 2, 1 minus 8, 7 over 8, which is, now we could use the calculator. Which is 5 pi over 256, and that's it.